So now we're going to learn how to make a simple delay in Max for Live. For that, what you need to do is you need to go to the Max for Live tab on the left hand side in Categories and Live, and go into Max Audio Effect and drag in the template for Max Audio Effect. I'm putting this after Keyscape, which is just like VST that has keys, and have a simple EP on this. So what we're going to do is we're going to open up the editor for the Max Audio Effect, and basically whatever you build is going to come in between this plugin and plugout. But now we're going to delete this, and we're going to bring in the plugin, which basically brings in left and right audio from live. Now, building simple delay works on delay lines. What delay lines are basically circular buffers that hold whatever sound you put into them for a certain amount of value, and you can read it back at a certain rate. So we're going to bring in the tap-in object and instantiate with a number. So what that is the maximum delay time, and we kept it at 1000 milliseconds, which is 1 second as of now. Now to read it back, what we need is a tap out object, and at what rate that it's going to read it, that's the tap out object. So it's going to read it 100 milliseconds slower than what it was built in at. So we're going to connect these both objects. What that basically does is when you connect both the tap in and the tap out object, it basically shares the same circular buffer circular buffer memory. Now since this is going to be a stereo delay, we're going to make 2 of those. I just selected it and held on Alt and copied it over. I'm going to put in the left over here and the right over here. Now what we're going to do is we need to attenuate the signal, and we do that by instantiating a multiply tilde and put it at 0.5. And since we need some kind of feedback option, we're going to feed this back into the tap out. Basically what we're doing is we are putting the delayed signal back into the delay so that we get some kind of feedback. I'm going to copy this again down here and put it over here. Now since it needs to come out, we're going to put a plug out object, connect the left and right. Now since we want so that we can control the dry and wet, so this is going to be the dry signal which comes straight from the plugin, and this is going to be the wet signal. To control how to control the dry and wet option, what we're going to use is a certain Max for Live object called the M4L balance 2. That's going to be M4L dot bal 2. What this basically does is if you open up the abstraction, it balances 2 stereo signals with constant power. So the first 2 take the first stereo signal, the second 2 take the second stereo signal, the last one basically blends between the 2. So we can instantiate a live.dial and change its prototype so that it's an amount. Now since we want it to be all the way on the left to be dry and all the way on the right to be wet, I'm just going to go on the inspector and change its percentage to a pan. There you go. Actually not a pan, I'm going to change, we're going to bring out a prototype of the pan and change that to percentage. Yes, that's how we do it. Cool. So connect that there, take these 2, put in the first 2, and take these 2, put in the second 2. So that's a basic dry wet, constant power changing. And what we can do is we can test it out. So I'm just going to make a small little clip over here, just put in some notes, just play that. So on the left, it's going to be that. On the right, you can already hear that the signal's delayed. And the middle, you have like a cross between the both. I'm just going to stop this for now. And what we're going to do is we're going to put in a certain amount of control for how much feedback we want. Now, audio in max goes from a value of 0 to 1, 0 being the lowest and 1 being the loudest. So what we're going to do is we're going to bring out a live.slider to control the amount of feedback that we have. And we're going to change the slider value. Instead of going from, I'm sure this goes from 0 to 127, if you test it out here. There you go. So we're going to change that to be 0 to 1. 0 to 1. So there you go. We get floating point outputs from 0 to 1. I'm going to change the short name of it to be feedback. Cool. So now we have a feedback value. I want it to 1, the exponent. That's not changing that. Let's see. Cool. So now, if we connect this over here, if we bring it all the way up, it's going to be a lot of feedback, and all the way down, it's going to be less feedback. But since we don't want to go from 0 to 1, because it's going to feedback like crazy, what we're going to do is it's going to make it 0 from 0 to 0.7. That's not going to make it so nuts. We can read the value and see on the top of 0.7, bottom it's completely 0. Cool. So this is all cool, it's all said and done, but what we need now is a way. I'm just going to change this to say try slash web. Cool. Now what we need is so that having it read back at 100 milliseconds is not a very musical sort of value. What we're going to do is we're going to put in note numbers so that we can choose at which beat in interval it delays. So for that, we're going to first make a live.menu, which is going to hold all our note values. Let's go here and change this 32N, 32N, 32ND, 16N, 16ND, 8N, 8ND, 4N, 4ND, 2N, 2ND. 2ND means the half note dotted. You can keep 1N and 1ND. That's a whole note delay. I'm going to copy that again for stereo signals. Now when we get this out and we feed it here into the tap out, and you just put an 8N, you might get an error message which says that tap out doesn't understand 8N, because the thing is that tap in and tap out values do not understand musical notes. They take the argument of they take the argument in milliseconds. So to help us convert that into milliseconds, we're going to use the translate object. So just bring translate and note values to ns. So now when we feed that in, put that in over here, we can give it note values. So if I just bring this up here, go back and play this. You can already hear that. Cool, that works. Now what we're going to do is we're going to put in a way so that we can change from it going from note values to just normal milliseconds. So for that, we're going to bring in a live.dial, and change this prototype so that it goes to time. So here we can set the amount in time. So this for the left and this for the right. And rename that L time, and rename this to be R time. Now we need a way so that when we hit a certain button, it's going to switch from the note values to the time. For that, what we're going to use is a G-switch tool. What a G-switch tool does, it takes two inputs and it sends out one output, and we have a third inlet on the left which controls which input it chooses. So we can put this over here and this over here. Have another one of these. Put time over here and measure time over here. Now what we're going to have is a live.toggle. Actually, not live.toggle. This is a live.numbox. No, it's not live.numbox. Keep forgetting about that. A live.button. That's what we're going to call it. Nope, it's not live.button. Live. It's live.text. Because we want to put in some text. There you go. Let me change its label to be sync, because we're basically syncing it. Cool. And if we monitor the output that sync gives out, it's going to be a 1 and a 0, which is basically what a toggle does. You can put this in here, and each time you hit sync, it's going to sync to these ones. When you unsync, it's going to sync to these ones. Just connect these back here. Yeah, there you go, it's already connected. This one. Cool. So it's always gonna, so that's gonna be how it works. But there's one issue that each time when you change the sync, its tapping is still gonna be on the last frequency that on the last value that it got. So we just need to rebang the U menus, or we need to rebang the time. So we're going to solve that. Let's bring a bang, bring this thing to the bang. Each time we hit this, it's going to feed that value. Each time we do this, it's going to feed these values. So we can test that by doing this. That's at 400 and 600. So I'm going to play this. And I'll change to that. That works. Now what we're going to do is we're going to learn about some filtration points. What I want to do is I want to filter my signal that's fed back. So how we're going to achieve that is using, we can use a few things. We can use a one-pole filter, which is just a one-pole filter. We can use the SVF, which gives us, which is a state variable filter, which gives us multiple outputs. It gives us a band, a low pass, a high pass, a band pass, and a notch. But what we are going to use is we can use a biquad. Now, the biquad filter basically it's a bunch of filters. It can be any filter that you want it to be, and the way we monitor the biquad filter is that the way we feed it inputs or signals is that it takes in coefficients, and we don't know what these coefficients are because it's some complex FIR math that we don't know. So there's something in Max called a filter graph tilde, which helps us know what these things are. So you basically just take that, put it over there, and actually we can have two of these for left and right. Just feed that over there. And what this is going to do is I'm just going to take this, put it in that, so it's in series. Put the input over here. Cool. this as well. Take this, put it over here, and then put it there. And take the output from your input from the bytecode. So that's the last thing that it goes out of. Great. Now this needs some kind of message so that it knows what kind of filter it is and all that kind of stuff. So we can give it a message saying that, okay, you're going to be a low pass filter. As soon as we do that, you see it changes to be a low pass filter. And we're going to, and the right three inputs that it takes is the sanctum frequency, the gain, and the Q. I know that since if you increase the Q, if you increase the gain of the filter a lot, it's going to feed back. So we're going to lock it to be only 0.9. We do that by going in the inspector of the filter and maximum constraints of maximum amplitude. We turn that to 0.9. So it's never going to go above 0.9. And we can change the amplitude to 0.9. There you go. So it's never going to go above that. Great. Now we're going to put a couple of light up num boxes to control the frequency. I feed that up here. We need something for gain, so just copy this over, change it to gain, and feed that over here. I think so this one gives you in dBs. Yeah, it gives you in dB and not amplitude. So I'm just going to do something, change this to be from 0.1, from 0 to 1, sorry. So light up num box, change this from the inspector to be 0 to 1, actually 0 to 0.9, because that's what we constrained it to. It shouldn't go above that, or you're just gonna have like issues in life. Yeah. And have another one for the Q. There we go. So you can change the Q of your filter. You can change the frequency, and you can change the gain. I wouldn't touch the gain too much, just leave it as it is. But now what I want to do is I want to change the filter types, and for that I'm going to put in a live.menu. And same thing, just going to go in the inspector and change its contents. So let's say low pass, high pass, and band pass. And take in the middle output because that's where it comes out from. And you see it's changing. Okay, now let's say if you don't want to set it by these numbers, but you want to set it by hand, there's a way that you can do that. And how you do that is, it says, like how you see it here, it says bandwidth out, it says query result, and it says the filter in, and it says the filter in index. Actually, you don't need to think about that. You need to think about the gain, the frequency out, the gain out, and the slope out. So basically, you need to set these numbers to be what comes out of here. So if we do that, we do set $1. So it just tells it that, okay, you need to set that to be that. And there you go. It reflects back what it needs to be. So I'm just going to copy that over for the gain and for the Q. And all I'm going to do is put it in here. Make sure this is Q. Yeah, that's Q. And just make sure that it looks neat. So hit Command Y and put these patch cables in here. Cool. So now we have that in our signal chain, and what we can do is, I'm just going to check real quick, is M4 Bal2 that I need to use, or is it Cross2? I get confused between these. Oh yeah, you want to crossfade between two signals of constant power. So let's see what it says. Output signal 2. Yeah. So let's just do this. Take these two, put it over here. Take these two, put it over here. And take this and put it over here. Because the M4L cross to, not the M4L bow to. So we're going to take the left output and left output, right output and right output. I think so this is going to work better. Let's sync it. And 8N and 8ND. Sounds good. Remove this bass note. And ignore the high register. Let's put some more notes. Cool. Let's play that. There you go. That works. We can filter out the bass, increase the feedback, change the sync so that it's bass and time, all the way wet, all the way dry, sorry, and all the way wet. Sync it back again, and get something across. And that's a basic filter. Well, now what we're going to do is we're going to put this into presentation mode, because this will look really bad if it's just by itself, and there won't be anything that we can actually touch when it's in over here. So we're going to put a few things into presentation. So we do that by selecting the object and hitting Command Shift P. So these, and these. Oh, what's the feedback? Cool. Now if you go into presentation mode, you see that's all that we see. Just going to quickly go and make sure the patcher always opens in presentation. Cool. So now we have basic. We know what the device's vertical limit is. So I'm going to take my filter first, resize it, and put it on the left. Just a choice. You don't need to do that way. Gonna make it a little bit big, just cause. Take the left time and the right time. Put it in here. Gonna take these both, which is again the left time and the right time here. Just gonna do this. Take the filter type over here. Take these down over here. And just create like a really simple UI. You can always put like a comment and say that, oh, this is low pass. Sorry, this is frequency, and that's gain, and that's Q. But for demonstration purposes, I'm just going to leave it there. Put the sync in the middle, put the feedback over here, and keep your drive node right over here. And make a window smaller, and just set go to view and set device width. Save this and give it some name like delay. And then close it. There you go. Ah, it's all that space on the side. Ah, I see. So move this in here and save it. Set device width again, and if I close it now, save it again. There you go. You have your basic delay.